Dad. What are you doing? I thought you had a conference today.
Hey, good morning. Nah, something came up. I thought I'd get up early, make breakfast for you on the day of your big test.
Yeah, we'll see.
You feel prepared?
I just want to pass it. You and Maria make it look so easy.
I'll let you in on a little secret. It's all about learning from failure. That's the key to science. Persistence.
So, I'm gonna fail my test. Thanks, Dad.
Hey, I have failed thousands of times along the way. In lab, in my research, in class.
Yeah, right.
Well, it's true.
Sure.
Well, the thing I learned from each one of those failures is they weren't failures. They're part of the process. If you can get through that, you will thrive.
Yeah, I guess.
Don't ever be afraid to be who you are, to take risks, and to learn from them. You know, I'm very proud of you. I always will be. I always will be.
Topology is a branch of mathematics which talks about connectedness of shapes.
The stuff that is in plants, chlorophyll, that makes possible the photosynthesis of the plants.
So this is liquid nitrogen. This is one of the coldest substances that we can make, period. It's negative 320 Fahrenheit.
Magnets then have this field around them that connects the North and the South Pole. There's also a fun property of magnets that it can create an electric field.
The MERSEC magnetic materials team has created the most powerful magnetic material to date. This discovery came about through significant teamwork with computational researchers testing material compositions that had never even been made before. Now, at the final stage, the magnetics research team here will test the properties of the magnet to determine its electronic and magnetic properties. This material is more than 1,000 times stronger than neodymium rare earth magnets.
We should borrow that super magnet for our project.
I don't know, man.
No one will notice. I'll bring it back Monday after the project.
How are you gonna get it out of here with nobody noticing?
Come on, man. Think of the subscribers.
Let's just get out of here before we get in trouble.
Our host for all she has done.
What's wrong?
I can't find it. I just put it.
You can't find what?
Okay. Andy, let's go. The bus will be here soon.
Hey, sorry, I didn't think the lab was busy.
Get your head out of the clouds. How did you miss the laser on sign at the door?
Wanted to see if you wanted to go to the coffee hour. I heard the guy that spoke on graphene was going to be there.
Maybe. How's your prep coming?
Well, I hit the wall, went through the wall, found another wall.
So we're ready for Monday?
Hey, we got the samples ready. All we got to do is do the presentation for the weekend.
We need this to work. I've wanted to work at Trask since I did a project on data storage in high school. Everything's riding on this.
Come on, man. We've been working on this for like 3 years. What's the worst that could happen?
I just wanted to know more stuff. Like every question I had, it was you know how if you're a 7-year-old and they try to annoy you by asking why again. I'm that kid that never stopped asking that.
My original spark of my interest in science came from really the beauty of nature, studying, what is our world, what is our universe about, right? And that's kind of in the big picture. You might think about things like, how does the universe work? And that's what, high energy physics and cosmology does. But materials are also, are a part of nature. It's just fascinating how the interactions between relatively small numbers of atoms in the periodic table can create all the varied behavior of the materials that we use in our society.
I was always fascinated by the fact that they all are made up of the same building blocks and on a very, very fundamental level, but when you touch something that's soft, it's very different from something that's hard. And so I at a young age was really interested in that as well. So I got into my head that I wanted to study quantum physics.
There's a certain feeling you have when you feel like you've understood something new, and it usually comes after a long period of time of not understanding. Solving a research problem is like trying to put a puzzle together, and you don't know what the final picture is going to be. And at some point it seems really hard and difficult, but a few pieces snap into place, and a few more will snap into place. And then all of a sudden, you see what picture is gonna emerge. And when you really feel like you've understood something new, it's a very satisfying feeling to say, aha, I think I get it, I've learned this.